Let's talk about how to find the domain of a function. If you go to Google and search for the definition of domain, you will see the definition: an area of territory owned or controlled by a ruler or government. So domain is related to an area of territory. An area of territory. So even the domain of a function relates to the area of territory. Now, in the previous example, h of x equals x minus 1 over x plus 3. When we completed this problem here, h of negative 3, we realized that negative 3 minus 1 over negative 3 plus 3 gives us negative 4 over 0, which is undefined. So this tells us that negative 3 is not in the area of territory for this particular function, because negative 3 caused an issue. You can plug in any other number and it wouldn't have caused an issue except negative 3. So negative 3 is not in the domain of this function h of x. Therefore, the domain of this function is all real numbers except x equals negative 3. Or to write it as interval notation, it would be negative infinity to negative 3 union negative 3 to infinity. Because on a number line, negative 3 will be the only number that has an open circle and that is not shaded. So every other number except negative 3 is in the domain. Set builder notation will look like this. Braces all x values such that vertical line there represents such that x cannot equal negative 3. But all this set builder notation is saying all other real numbers work except x equals negative 3. That's what it's saying. So, what are restrictions that you have to be concerned about when finding the domain of a function? First, when the denominator is 0, we don't like to when we have an undefined situation. So we need to figure out what x value or what input value will cause an undefined situation. Also, when there are negative numbers under the even roots. What I mean by even roots, square roots, for example. We do not like negative numbers under that. We're not in the imaginary number system just yet. We're still in the real number system. So we only want numbers that are under that radical to be greater than or equal to 0 at this point. So no negative numbers. This is an even root radical because this is considered to be a 2 here. So a fourth root of x, for example, will also apply. The sixth root of x will also apply. Now, here are all the 6 scenarios you will deal with when finding the domain of a function. The first scenario is if you have a polynomial only. So we have a polynomial f of x equals 3x minus 4, or f of x equals negative 3x squared plus x minus 1. In this situation, you can plug in any x value and there will not be an issue. No issues if it's just a polynomial. So your domain is going to be equal to all real numbers Or if you want to write it in interval notation, negative infinity to positive infinity. That means all real numbers. Any number you plug into x for this first situation would not cause an issue. And there's a symbol for all real numbers. It looks like a double R. All right, next, you have a situation where you have a fraction only, x minus 1 over x plus 3. So here's the same situation as before. Same situation. So in order to figure out what's not in the domain, the instructions are, and I put the instructions here under domain. The instructions are to set the denominator to not equal 0 and solve. So here we go. Set the denominator. The denominator is x plus 3 here. Set it to not equal 0 and solve. So we're going to subtract 3. X cannot equal negative 3 as we said before. And again, choose one of the 3 ways I've taught you to write the domain. So for example, one way could be set builder notation. Braces x such that x cannot equal negative 3. That is the domain. Let's go to square root only. F of x equals the square root of x plus 1. We want the numbers to, under the radical, to be positive, meaning we only want to produce positive numbers under this radical. So in order to figure out what x values will work, we set what's under the radical to greater than or equal to 0 in this case. So what's under the radical? X plus 1. We set it to greater than or equal to 0. Subtract 1. X has to be greater than or equal to negative 1. Therefore, your domain could be written, let me write it in words, all real numbers such that x is greater than or equal to negative 1. So that's one way to write your answer. Or let's look at a number line. We have negative 1 here. Where should we shade on that number line? We should definitely shade to the right of negative 1, but we should also either bubble in negative 1 because it's equal. It can't be equal negative 1, or you put a bracket. Both mean include negative 1. The bracket or the parenthesis mean include. Open parenthesis or open circle means exclude. So let me put open circle or parenthesis means exclude, okay? But the bracket, or if you bubbled in, that means to include that number. And here you can include that number, negative 1, because it says if you plug in a negative 1, that is totally fine. And you can test it. If you plug in negative 1 plus 1 here, you get the square root of 0, which is 0. 0 under a radical is perfectly fine. 0 in the denominator is what we have an issue with. All right, so you could write this in interval notation as bracket negative 1 all the way to positive infinity. Another way you could write in set builder notation, braces x such that x has to be greater than or equal to negative 1. So those are 3 different ways you could have written that answer. Choose a way that you like the best. Square root in denominator. So we have a square root in denominator. Notice I chose the same exact radical, square root of x plus 1. This time, though, that radical is in the denominator. So what is the difference? If it's in the denominator, we do not want it to equal 0. So these instructions here state set what's under the radical to greater than or equal to 0 because it was in the numerator. But now that we have it in the denominator, we have to set what's under the radical to only greater than 0, not equal. We do not want the denominator to equal 0. So here we have x plus 1 greater than 0. Subtract 1. X has to be greater than -1. Therefore, the domain is all real numbers such that the x has to be greater than -1. Or you could write it as parenthesis -1 to infinity. Or you could write it in set builder notation. All x values such that x has to be greater than -1. Let's go to the square root in the numerator. But notice we have a square root in the numerator and a denominator. So we have two situations going on simultaneously. First, we know that the denominator, we need to set the denominator to not equal 0. So we know that x squared minus 4, we don't want that whole thing to produce a 0 in the denominator. And then we can factor x squared minus 4. So that's x plus 2 times x minus 2. Set each factor to not equal 0. So that's x plus 2 equals 0. Subtract 2. We don't want x to equal -2. And we don't want x to equal 2. So that's just for the denominator. Let's talk about the numerator. For the numerator portion of the problem, we don't want x plus 1 to end up being negative. So we say greater than or equal to 0. So we subtract 1. We want the x's to be greater than or equal to -1. Therefore, we have two situations going on here. We have to put this information together. On one side, we know that we don't want x to be -2 or 2. It can be anything else except these two values. And the other side, x's can be greater than or equal to -1. So the best thing to do to pull these both together is probably draw a number line. And for both situations, use a different color. So we have, let's put the pertinent numbers here, -2, -1, and +2. One is saying we don't want it to be -2 or 2. So we put open circles because we don't want it to equal -2 or 2. But it can be everything else except that. And the numerator is saying we only want numbers that are greater than or equal to -1. So I'm going to use a different color for that. So bubbled in here, we want this, right? This is okay. But when is it orange and purple at the same time? That's the final answer. So the domain would be start with -1. You would go to 2. Let's put a bracket for -1 because -1 was okay for both numerator and denominator. 2 is not okay for the denominator, so we're going to have to put a parenthesis there because 2 is not included for the denominator. Because if we plug a 2 in here, think about it, we get a 0. We don't want that. Then we use the union symbol. We pick back up at 2 and we go all the way to infinity. All right, let's go over some additional examples. Find the domain of each of the following functions. Let's begin with f of x equals 2x over x plus 1 times x minus 4. So are there any restrictions? Again, there are only two restrictions you have to be concerned about. Whether we have a denominator or whether we have a radical. Denominator, radical. Those are the only two restrictions. Right? So notice for our first function, we have a denominator. So we have a fraction, right? So for a fraction situation, the instructions say, set the denominator to not equal 0 and solve. So follow the instructions. These are all the scenarios right here that you're going to be dealt with. Study the scenarios and study the instructions that I have posted under the word domain. So for this particular problem, we are going to set the denominator to not equal 0 and solve. So the restriction again, yes, we do not want the denominator. We don't want it to equal 0. So we don't want x plus 1 times x minus 4 to equal 0, right? And then if we solve that, we don't want x plus 1 to equal 0 or x minus 4 to equal 0. We don't want x to equal -1 or 4. So what is the domain? All real numbers except those two numbers. All real numbers except x equals -1 or x equals 4. All right, next we have h of x, x plus 5 over 2x minus 3. Same situation. We don't want that denominator to equal 0. Therefore, we set the denominator to not equal 0 to figure out what we don't want it to be. We don't want 2x to equal 3, and we don't want x to equal 3 halves. So the domain is all real numbers except x equals 3 halves. And of course, you can write it in 3 different ways. So maybe I'll go back up to the first one, show you a way to write that one. Another way to write this one would be from negative infinity to -1, union from -1 to 4, union 4 to infinity, because we had two numbers that we had to exclude. And also, you could have written it as set builder notation, braces x such that x cannot equal -1, x cannot equal 4. That is good enough. Let's go to j of x. Are there restrictions? Do we have a radical? Do we have a denominator? No. Therefore, the domain is all real numbers. What's another way to write that? You could write negative infinity to positive infinity, or you could write all real numbers, the symbol for all real numbers. Next, we have k of x, 7 over x squared minus 8x minus 20. Again, we have a denominator. So yes, we do not want x squared minus 8x minus 20 to equal 0. Therefore, how would you solve an equation that looks like this? Well, it's not a linear equation, so we can't add 20. Therefore, we need to use other methods, other strategies to solve for x. Here, this is a trinomial that can be factored. So our factors would be that x and x, what are factors of -20 that add to -8? That would be -10 and +2. Therefore, we don't want x to equal 0. We don't want x minus 10 to equal 0. Therefore, we don't want x to equal -2 or 10, right? So all real numbers except those two numbers, -2 and 10. All right, let's move on to m of x. M of x here, again, we don't want our Denominator, x squared minus 12x equals 0. So we factor here. The GCF is x. So x times x minus 12. We don't want x to equal 0. And we don't want x minus 12 to equal 0. So therefore, we don't want x to equal 12. So all real numbers except 0 and 12. All right, next, n of x equals x squared plus 1. There's no denominator. There is no fraction or radical, so no restriction here. All real numbers. Moving on to p of x equals the square root of x plus 4. What is the restriction? Well, restriction this time is we encountering a radical and there are negative numbers under the even roots. That will cause an issue. So we have a square root. What do? We set what's under the radical to greater than or equal to 0 this time. So we change up to these instructions here. So what's under the radical? X plus 4. So yes, the restriction is that x plus 4 must be greater than or equal to 0. We subtract 4 to get x is greater than or equal to negative 4. Therefore, our domain is all real numbers. I changed the terminology a little bit when I talk about radicals, such that the x's have to be greater than or equal to negative 4. Or you could write the domain as bracket negative 4 to infinity. And you can draw that on a number line. Right? Negative 4 is right here somewhere. It says equal to negative 4. And everything greater than negative 4 is this way. So this is how you will write your domain in interval notation. Or we can write this in set builder notation. Braces, x, all that means that x right there means all real numbers. That vertical line means such that x has to be greater than or equal to negative 4. All right, next, do we have a restriction? Well, we do have a radical, but it is not an even root radical. That 3 is an odd number. So there is no restriction actually on this particular radical because it's an odd root radical. And you can have negative numbers under cube roots, just not square roots. So all real numbers is the answer. Now let's get to f of s equals square root of s minus 1 over s minus 4. Here we have a situation. If we go back to our scenarios, like the last one over here, where we had a radical and we had a denominator at the same time. And we have to take into account both numerator and denominator restrictions. Therefore, we definitely have restrictions. One part, the numerator. Let's talk about the numerator. S minus 1 can be greater than or equal to 0. So we know that s can be greater than or equal to 1. But on the other end, denominator, s minus 4 cannot equal 0. Therefore, s cannot equal 4. So we have to draw a number line and see how can we put both of these together. So for the numerator part, at 1, it's saying that s can be equal to 1. You can put a bubbled in circle or bracket here, or like this. It can be greater than, so it's going in this direction. But the denominator is saying at 4, let's say 4 is here, is not included here. All right. It can be included everywhere else except at 4. So how do we write that as a domain to pull it all together? Let's use interval notation, for example. Well, when we have the orange and purple at the same time, it starts at 1, right? So domain starting at 1, and then it's purple and orange at the same time all the way to 4. Parentheses, there's a hole at 4 because S cannot equal to 4. Then union 4 to infinity. That's interval notation. If you want to write it in set builder notation, it could be written as, this time we're going to change that X to an S. How about that? Well, you could put S cannot equal, well, numerator says S can be greater than or equal to 1, and S cannot equal 4. You can put that together like that. All right, let's go to what you probably remember domain and range to be back in middle school, maybe. Consider the relation. So a relation is a set of points. We have a set of points 1, 5, 2, 8, 3, 11, and 4, 14. Turns out the domain, if you are given the exact x values, then your domain is just your x values, right? This is xy, xy, and so on. So your domain is, we always use braces to write it, 1, 2, 3, 4 for this particular relation. And then the range is, you guessed it, your y values. So we have 5, 8, 11, and 14. However, is this relation considered to be a function? Well, in order to be a function, no two-ordered pair have the same first component. That means your y values can't have the same x. All right. So, for example, consider the relation 2, 1, -2, 3, 2, 5, 6, 3. Notice that 2 is going to, that x value 2 is going to 1 and is going to 5. That's a problem. You want to be able to predict whether 2 is associated with 1 or 5, not both. That's a little unpredictable. So this is not a function. However, the one earlier is a function because there is an x value going to one y value. You know that if we plug 1 in, we get our 5. We plug in 2, we get our 8. But in the second situation, is it 1 or is it 5? All right. So that's not a function. Here's something that may be more relatable so you can understand it better. Determine whether the relation represents y as a function of x. All right. So let's look at this. You have a student in a class. You have Annie has a 92. That's her final grade in the class. Benjamin, 78. Charles, 71. Dennis, 80. Annie, 50. Now this not different Annies. It's the same Annie. Is this possible? Have one student to end up getting 2 different final grades in the class. So this is not a function. All right, we're going to treat this side as the x and this side as the y. We only want Annie to have 1 final grade. It doesn't make sense for her to have 2 final grades, so not a function. All right, here we have some points on a graph. And so it might be best for you to label the points. For example, this point here, 2, 3, this point here, 1, 0, this point here, 0, -1, this point here, negative 1, 0. This point here, negative 2, 3. So if we examine our x values, they are all different. So that is a good sign. You're all going to different y values. So this is a function. This concludes our lesson on finding the domain, and also when you have a relation, finding the domain and the range.